Hello, today we're going to solve an interesting equation that involves both polynomials and fractions. The equation is x squared plus the quantity x over x plus 1 squared minus 3 equals 0. Our goal is to find all the real values of x that make this equation true. As a quick note, since we have x in the denominator, we must remember that x cannot be -1 because division by 0 is undefined. Let's begin by looking for a pattern. Notice we have an x squared term and an x over x plus 1 term squared. It's tempting to combine everything on one side and look for a way to factor it, but that would lead to a complicated polynomial. A more clever approach is to see if we can transform this equation into something simpler using a substitution. But first, let's look for a relationship between the two main terms. Let's focus on the term being squared, which is x over x plus 1. That's x divided by the quantity x plus 1. We can rewrite this fraction. Let's add and subtract 1 in the numerator. So x over x plus 1 becomes x plus 1 minus 1, all divided by x plus 1. We can then split this into two separate fractions. This gives us the quantity x plus 1 over x plus 1 minus 1 over x plus 1. The first term simplifies nicely. As long as x is not 1, x plus 1 over x plus 1 is just 1. So we found a new way to write our term. X over x plus 1 is equal to 1 minus 1 over x plus 1. This is a very important connection. Now let's bring back the full equation. We have x squared plus our term squared equals 3. That's x squared plus the square of the quantity x over x plus 1 equals 3. And remember the substitution we just found. X over x plus 1 is equal to 1 minus 1 over x plus 1. Substituting this into our equation gives us x squared plus the square of the quantity 1 minus 1 over x plus 1 equals 3. This looks more complicated, but it's leading us somewhere. Let's expand the squared term using the identity ab squared equals a squared minus 2ab plus b squared. Expanding the term, we get 1 squared, which is 1 minus 2 times 1 over x plus 1 plus 1 over x plus 1 squared. This equals 1 minus 2 over x plus 1 plus 1 over x plus 1 squared. Let's put this back into the main equation. Our equation is now x squared plus 1 minus 2 over x plus 1 plus 1 over x plus 1 squared all equals 3. Let's regroup the terms in our equation to see if a pattern emerges. Rearranging the terms, we have x squared plus 1 over x plus 1 squared minus 2 over x plus 1 all equals 3. Look closely at the first three terms. Do you recognize the pattern? Highlighting x squared minus 2 over x plus 1 over x plus 1 squared. This looks like a perfect square trinomial. Specifically, it resembles a squared minus 2ab plus b squared. This pattern is often called a perfect square identity. But what is a and what is b? If you look at our terms, a could be x and b could be -1 over x plus 1. Let's check it. If we square the quantity x minus 1 over x plus 1, we get x squared, minus 2 times x times 1 over x plus 1, plus 1 over x plus 1 squared. That is x squared minus 2x over x plus 1 plus 1 over x plus 1 squared. This is not the same as our terms. Let's try a different combination. The middle term has x as the numerator, but in our expression, the middle term is just 2 over x plus 1. So our a term can't be x. The terms are 1 over x plus 1 and x. What if we use them in the other order? Let's try squaring the quantity 1 over x plus 1 minus x. This equals 1 over x plus 1 squared minus 2x over x plus 1 plus x squared. This is exactly what we have, just in a different order. Tat. Aha! We found the perfect square. Our first three terms can be written as the square of the quantity 1 over x plus 1 minus x. Let's substitute this back into our main equation. Our equation becomes the square of the quantity 1 over x plus 1 minus x plus 1 equals 3. This looks much simpler. Now we just need to solve for x. Subtracting 1 from both sides gives us the square of 1 over x plus 1 minus x equals 2. This is an equation of the form z squared equals 2. Taking the square root of both sides, we get two possibilities. 1 over x plus 1 minus x equals the square root of 2, or 1 over x plus 1 minus x equals the negative square root of 2. Let's solve these two equations separately. For the first case, let's work with the positive square root. We have 1 over x plus 1 minus x equals the square root of 2. To get rid of the fraction, we multiply the entire equation by the denominator x plus 1. This gives us 1 minus x times the quantity x plus 1 equals the square root of 2 times the quantity x plus 1. Expanding both sides, we get 1 minus x squared minus x equals the square root of 2x plus the square root of 2. Now, let's rearrange this into a standard quadratic equation. X squared plus bx plus c equals 0. Moving all terms to the right side gives x squared plus x plus the square root of 2x plus the square root of 2 minus 1 equals 0. Factoring out x from the middle two terms, we get x squared plus the quantity 1 plus the square root of 2 times x plus the quantity square root of 2 minus 1 equals 0. This is a quadratic equation, and we can use the quadratic formula to solve for x. The formula is x equals negative b, plus or minus the square root of b squared minus 4ac, all over 2a. In our equation, a is 1, b is 1 plus the square root of 2, and c is the square root of 2 minus 1. Let's calculate the discriminant b squared minus 4ac first. The discriminant is the quantity 1 plus the square root of 2, squared minus 4 times 1 times the quantity square root of 2 minus 1. Expanding this, we get 1 plus 2 root 2 plus 2 minus 4 root 2 plus 4. This simplifies to 7 minus 2 root 2. So our two solutions from this case are x equals negative 1 minus the square root of 2, plus or minus the square root of 7 minus 2 root 2, all over 2. We can see that the discriminant, 7 minus 2 root 2, is positive, which means we have two distinct real solutions. We can also verify that neither of these solutions is equal to 1. Now let's tackle the second case, where we use the negative square root. We have 1 over x plus 1 minus x equals negative square root of 2. The process is the same as before. First, we multiply by x plus 1 to eliminate the fraction. This gives us 1 minus x squared minus x equals negative square root of 2x minus the square root of 2. Rearranging into a quadratic equation, we get x squared plus x minus the square root of 2x minus the square root of 2 minus 1 equals 0. Factoring out x, we get x squared plus the quantity 1 minus the square root of 2 times x minus the quantity square root of 2 plus 1 equals 0. Again, we use the quadratic formula. Here a is 1, b is 1 minus the square root of 2, and c is negative 1 minus the square root of 2. Let's calculate the discriminant. It's the quantity 1 minus the square root of 2 squared minus 4 times negative 1 minus the square root of 2. Expanding this gives 1 minus 2 root 2 plus 2 plus 4 root 2 plus 4. This simplifies to 7 plus 2 root 2. So our two solutions from this case are x equals negative 1 plus the square root of 2, plus or minus the square root of 7 plus 2 root 2, all over 2. Again, the discriminant is positive, giving us two more real solutions that are not equal to 1. So, by using a clever algebraic substitution and identifying a perfect square, we transformed a complex equation into two solvable quadratic equations. We found two solutions from the first case and two solutions from the second case, giving us a total of 4 real solutions for x. The key insight was to recognize the relationship between the two main terms in the original equation, which allowed us to make the substitution x over x plus 1 equals 1 minus 1 over x plus 1. This created an expression that could be factored into a perfect square. This problem is a great example of how looking for hidden structure and symmetries in an equation can be much more effective than direct algebraic manipulation. To quickly recap our strategy, we were faced with the equation x squared plus the quantity x over x plus 1 squared minus 3 equals 0. First, we analyzed the term x over x plus 1 and found a new expression for it. This key substitution was x over x plus 1 equals 1 minus 1 over x plus 1. Second, we expanded and rearranged the terms, carefully identifying a perfect square. We noticed that x squared minus 2x over x plus 1 over x plus 1 squared could be written as the square of the quantity 1 over x plus 1 minus x. Finally, We solved the resulting simpler equation by taking the square root and solving the two separate quadratic equations. This led us to 4 distinct real solutions. Well done!